Okay, can you see my screen, everyone?
Yep.
Okay, perfect. Okay, first I create a little presentation so we can understand all the terminology and the new terms on the Docker technology, and then we can do uh, little project with Docker. Okay, so first, what is it? Docker is a platform for developers and sysadmin to develop, ship, and run applications. It consists of two parts: the Docker engine, that is responsible to create the images, create and run the containers, and the Docker Hub, that is responsible for storing the images that we create or build. Okay, why do we need Docker? These are some reasons. We have faster delivery of your applications. Why is faster? Because what we run locally through boot to Docker or Docker itself in a Linux machine, it's exactly the same image that we are going to run on the cloud. So we don't have to worry about the different dependencies or things that can break on the cloud, and we don't know why. Why it's deployed and scaled more easily? Because the the workflow on Docker is similar to Git, where you push code to GitHub and then pull the code in another machine. In this case, you push the image. It's basically all the binaries that you need through to the Docker Hub, and then you pull on the server and run it. You have more a higher density and run more workloads because you can run multiple containers in a machine, and these containers can be completely different. One container can run PHP, and another container can run just Node.js, for example, and because of those are containerized, the host machine doesn't affect. So you can have different kind of dependencies. For example, an application can have PHP 5.4 requirement, and another 5.6, and you can run the same the two containers in the same host. And it's faster deployment.
People to the shit show. Keep going.
Okay, faster deployments means that it's easier to manage the containers directly on the hosts. Very high level of how this works. We have three parts. The Docker client, that is just a binary, an executable command that can interact with the host through the Docker daemon, that is the server. And the Docker index is where Docker index or Docker registry is where we store the images. We can upload or download the images from there. In the host, we can have multiple containers, as you can see on the picture, and the client execute commands on the daemon to interact with the containers. Okay. Here are some terms that let you clarify a little bit how this works. The Docker client is just a binary that interacts with the API. The API is a REST API that normally is exposed through a socket, but it could be worked as HTTP also. The Docker daemon, that is the server that is waiting for commands to do on the server. The Docker registry is the store. Basically, the Docker Hub, I think, store images on S3, and there is a Docker project that you can start a Docker registry in a private cloud, so you can have all your images there without having to pay them for hosting that. The image, Docker image is like a template. You have all the file system structure of an installation of, for example, the Ubuntu operating system, with Apache and your web applications, and you have and you build this image in steps. So each step you build, for example, you have Ubuntu as a first step. Then you install Apache is the next step. Then you install your application is the next step. Each step is an image layer. And this concatenation of these image layers provide the full image. Docker uses, for the image layers, Docker uses the union file system that it allows you to combine different layers of structures of the file system in a single one. So when you run the container, you see a full, a normal file system structure, but this is the union of different file systems. It's something like the Koana Cascade file system. It's something similar. And the container that is when the image is running. So what the Docker does when the container is running is take the image and create a file system in there and run the commands that you let them you wanted to run. And the Docker file is how you create an image. You can create an image manually by, for example, running an image from Ubuntu, for example, then going there, install, run apt-get install Apache, then Docker commit, and you create a new image from there. But it's easier if you use a Docker file where you have all the recipe to create the image in one place, and it is repeatable. Okay, compared to VM, the Docker containers are super lightweight. The VMs are best suited for allocate chunks of hardware, but containers operate at the process level, so it's just an isolated process on the same host, and between all the containers share the same kernel. That is the kernel, the host of the kernel. Okay. Here's what happened. For example, in this command, the docker run is the minimal command, the hello world. Let me show you here. If I run docker run ubuntu, what it does right now, it seems instantaneous, but what happens is that it first checks if the image is available locally. I already run this command, so the image was already pulled from the Docker registry. Then creates a new container with the template from the image, allocates a file system, and mounts a read-write layer. So you have the image as an initial read-only file system, and then you mount a new layer so you can write to the file system. Allocates the network and the bridge interface to communicate between containers and with the external world. Gives the container an IP address, and then execute the process you specify. In this case, it's the command is echo. If we don't want, for example, echo, we want bash. We just need to specify some other parameters on the command that allows me to interact with the command. So it allocates a TTY, and I can run the commands here. For example, I can remove everything. And don't worry about the host, because the host is completely isolated from the container. Okay, and captures and provides application output is the way how we interact with the bash. So we can interact directly through ATTE, or we can run as a daemon, and the things that the command goes to the standard output is going to the logs of the Docker daemon. Okay. Some commands that are used very frequently. Docker images allows you to list all the images that are local to your host. In this case, for example, I have MySQL versions 5.5 and 5.6. PHP I have 5.4, and I have a version of PHP that only uses FPM. Docker PS allows you to list all the containers that are running in that host. In this case, I'm running the Docker in the Optum demo host. So right now we have two containers: the web container and the MySQL container that is serving the application. Docker PS.
Two Docker containers, you said?
Yeah, one for the application that contains PHP, FPM, and Lite, and another for the database. Okay, for Docker PS-A, it lists all the containers stopped that are not deleted. These containers, if you don't want, you can restart it, or yes, launch them again, and the data you store there are still there until you delete it. Docker run -d allows you to run an image in daemon mode. For example, MySQL can run in -d mode. The Docker run -it allows you to interact in the case of the bash. Docker exec is interesting because you can sort of log in to the container without having to install SSH, for example. So in this case, I can docker exec -it. I want to enter to the running container web and in bash mode, and here I can explore what's happening inside of the container. Yep, these are all the logs that are producing inside the container. Okay, another thing, Fig it's not part of Docker, but allows you to simplify a bit the workflow with Docker, especially in development environments. I've created a little demo here. Don't want to stop. Let me start another. Okay. The code is really simple. We have three files. The one is the Docker file. In this case, I've added another thing here. But the simple structure of this file is you select an image from what you want to start the process to build your image. In this case, I've selected PHP 5.6. Then you add the code in the local path to a /code inside the container, inside the image, and then you set that the work dir, what is the startup directory when the container runs, is going to be /code. Okay, and for Fig there is another file that says how your environment is going to be deployed. For example, in this case, I'm going to need a web container and a database container. The web containers is going to build through the Docker file that I already defined. The commands to execute is right now it's just the simple built-in server of PHP. I'm going to mount a volume. A volume is how you can put a local directory from the host inside the container, expose it as a directory there. So any change I do in the files in the hosts are going to be are going to show on the container too. So it's like a directory sharing in VirtualBox. It's something like that. It's not the same, but it can be think as that. Then the way you interact between two containers is through links. So in this case, I'm going to set that the web container is going to be linked to the database container. That is expressed later. And the ports, it's specified how I want to expose the things that is running on the container to the world through the network. In this case, I'm saying that the 8000 port on the container is going to be exposed in the 8000 port on the host. Okay, and for the database is more simple because I'm going to use an already baked image from the Docker Hub, and I'm going to pass an environment variable to set the password of the admin user. Okay, so right now I'm going to delete them so you can see. Okay, so the first thing I can do is just fig app. Fig app will check if the image is already built for the web application and download the database image from the hub. If those are already locally created, that's just going to start the containers and link them. It saves you a lot of typing with the Docker commands because they tend to be a little bit larger. In the case of the Docker web, it's going to be something like docker run -d -b /code -b specify the volumes, -b specify the ports, -link specify the database, then you set the web image and then execute it. So instead of typing all of this, Fig helps you declaratively specify how Docker is going to run. So in this case, the image is already running. Let's see if it's working. Okay, so the code for the index is super simple. I'm just executing a PDO connection. The host is called DB. DB is passed through to the containers as an environment variable. So DB DB is writing in the host file with the IP assigned by Docker. So I can just specify the host through a name in this case. And then I just selecting the actual date on the server. And every time I update, the data change because of the time on the MySQL database. Okay, that is how we normally create environments for Docker. I don't know if you have any questions until here to continue with the Dockerization of the MapTimer application.
How big are the images, like the containers? And are they just standard, kind of comparable to a VM?
Sorry, you said the size of the images?
Yeah. So if in this instance, you have
Yeah.
two
Let's see.
containers that are running on a Ubuntu quote image, right? Just a Docker image.
Yeah, it's a small. I think it's a micro host. Yeah, right now we are using 5 gigabytes. If we run Docker images, we are going to see how they the size. For example, PHP or MySQL 5.6, it's 500 megabytes.
Are you running this on your local?
No, this is on the Fibroblast server, but you can run locally. Uh, but the architecture there is a little bit different. The Docker binary, the Docker client, is going to run locally on Mac, and the Docker daemon is going to run on a VirtualBox machine with a minimal operating system, just to have Docker daemon running. And so every time you execute commands in your local, you are actually running on the VirtualBox.
On the VirtualBox?
Yep.
So it is a little bit like Vagrant. I know that it's not; these aren't virtual machines, but
Yeah, in the case of Vagrant, for example, if you have two projects, you are going to have two virtual machines that are consuming space. In the case of the boot Docker, when you have two projects with Docker, you have one single virtual machine and different images in there, but you can run multiple projects in the same virtual machine.
so let's say that we have 15 different projects that have subtly different environments. Maybe PHP is the same, but maybe some are using Ratchet or some are using like a PDF generating library.
Yeah, probably. I would say that every project is going to consume 1 gigabyte.
1 gigabyte.
Yep, because it's MySQL plus the PHP plus your code.
But as long as the version of Ubuntu is the same, like the underlying operating system, then
No, no, you can have, for example, for one project, you can build PHP from CentOS, and for another project, you can build PHP from Ubuntu.
But what I was getting at was if you wanted to, obviously I don't want to give like 100 gigabytes of hard drive space to this thing on a local environment, and that's an exaggeration. But if all of our apps were running on the same version of Ubuntu, then Docker would only download that VM one time, right?
Yeah, that's right.
So the containers would be different, but the underlying OS uses the same image.
Yeah, because of the image layering, you can start from Ubuntu 14, for example, and then install PHP 5.4 there, and in another project use the same Ubuntu image and install PHP 5.6. Both images have the same ancestor, that is Ubuntu 14. This Ubuntu 14 is not going to change and is going to consume the same space.
Yeah, so it's interesting.
How does it deal with persistence? Like the most obvious thing that comes to mind to me is logs, but I mean, there's a lot of other stuff that you would deal with there. So like if I spun up a bunch of these containers, PHP, for example, is that log going to end up as part of that container image on my machine?
Yeah. As long as the container is running, those logs are going to be there waiting until you delete the container. Normally, the application containers are going to be ephemeral. Uh, you should be able to delete the container and run it again without issues. But for logs, you should be able to have another container, for example, that read the logs and send it to another part or back up it, to not leave it on the containers because they are considered ephemeral. And
Right. So ideally, you don't want the logs to end up there, but for those type of activities, by default, they get written to that image.
yep, they are going to be in the container, not on the image, in the running container.
So the big benefit is, if an environment does change, the environment effectively gets stored in something like version control, and we wouldn't have people
Trying to install.
developing and running and building off of the same environment. There wouldn't be any more.
It's a consistent development environment, yes. For example, in this case, I created, when I built the fixed sample, I created an image. And this image can be exported as a tar file. And this tar file you can download to your local and just load with docker load tar file, and you are going to run it again without having to build it, like downloading all the files from the from the Debian repositories, etc. You just need to download the tar file and start it.
What is your? I mean, you've used this on a couple different apps now, right? I know you built Fiberblast on that. What else have you built on it?
I run Fiberblast there. I run the MEF timer mono version to run on Linux, just for fun. Basically, not install all the mono things in the host, just on an image in the Docker, and just start from there. Whereas I've tried to create a Docker file for ppmd, but I haven't finished it there yet. I think that's it. Mostly, I've played with other side projects with Docker, but smaller ones.
And what did you think?
I like it very much. The idea of having super consistent environments is a big plus. I haven't used it too much on production deployments because of we haven't had the chance. But for development, is super nice. Right now, the Docker state of the art is that right now the Docker containers can be linked in the same host. But when you want to deploy to a cluster, you have to use something else that is right now it's not provided by Docker. They are trying to have a tool to orchestrate that. I think it's called Docker Swarm, to deploy containers to different hosts in a cluster, but it's not finished yet. I've seen that you can deploy Docker containers with Mesos, but I think that's for the big leagues. I think Twitter uses that. It uses Mesos to deploy Docker containers, to schedule Docker containers. Google has another way to deploy the Docker that is internal for them. And Heroku is doesn't use Docker, but it uses the technology below Docker, that is Linux containers, and that's the way how Heroku works. Each dyno is compared to a container in Docker.
So if I were to use this with Leo, for instance, I would of course have images for development, which we could share with developers or use to push to the demo environment. And then when I were pushing to the production environment, for now anyway, I would probably just have a virtual machine image with Docker set up and running on it and swap it out like we currently do on Amazon? Or do you think that that workflow would be totally different? Like I would just swap out the image or something then?
I'm not sure. How do you swap the images on virtual machines?
Well, like if you have a pool of VMs that are built from the same image,
Okay.
the same image. So I would just update that image with the new Docker container setup and then tell Amazon to let that go? Or do you think it's much better managed through Docker directly, or you just don't know yet on production?
Yeah, I think it's better in Docker because the only thing you have to do is build the new image, certify that it works on stage or development, and then the same image it just pushed to production because you don't have to change anything else on production. You already certified that the image is working on stage, and you just push the production and change the config variables to connect to another database, and that's it.
Okay, but you were saying that they're not really set up to deal with deploying to clusters. So I'm wondering, like, if I were doing a deploy and, you can't push out the whole thing at once if there's multiple machines. And what if something goes wrong? Like, do you know if it has a way of dealing with rollbacks or anything like that easily?
Yeah, you can, for example, in each host, you are going to have the images, the different images you are working with. So it's like GitHub. You are going to have a tag inside each commit. So if you want to run a different tag in production, you just have to specify what tag you want to run. For example, in the case of Ubuntu, you have the tag 1404, okay? But you can start another container with Ubuntu 1204, and that will run the previous version. In the case of your applications, you are going to have a different tags, for example, v1, v2, v3. When you deploy v3 and there is problems, you just want to roll back and deploy and run v2. Just run v2 because the image is already deployed on the cluster.
Okay, and so it's a relatively fast thing to switch in between two images that are already on the machine. Then there's no,
Yeah.
like your Hello World example obviously is pretty fast, but if you have like a 400 megabyte PHP image, that still loads pretty much instantaneously then.
Yeah, it's the same amount of work.
Nice.
Yep. There is some approaches to do zero time deploy. When you normally these containers are going to be behind a reverse proxy. So what you do is run a container with the old code that is running right now. You pull the image from with the new code. You start a new container with the new code with a different port. Then on the reverse proxy, you just swap the ports, and you start serving you start serving the request from the new port. And then after the things are okay, you just stop the old image or the old container, and that way you don't lose any requests between the deploys.
Yeah,
Okay, that makes sense.
So, and again, sorry if this is a naive question, but if you're using this, your development environment, all of your starting and stopping of services, all of your, the bin start scripts that we write, all of that stuff would just be managed through the Docker file.
Yeah, in the Docker file, when you have when you have a container that manage multiple processes inside the container, the recommendation is to use Supervisor to manage all the startup scripts. So let me show you. I think I have in Fibroblast Supervisor.
Thing.
Yeah. In this case, Fibroblast start with PHP FPM and then Lite, and that's it. So with Supervisor, you start Lite and make sure the Lite is auto restarted if finished, and the same thing with PHP FPM. That way you can, when you run the container, you always know that those two things are going to be running.
Cool. Well, I'll probably actually try to get the timer app running myself.
Okay, perfect.
Just to like stab at it. Could you push yours up like in a separate branch so that I could, if I, you know, get lazy, I could just look at it. I'm gonna have to run right now. You guys can keep going. But I'll probably try this afternoon just to see what it's like.
Okay.
Thanks a lot for putting this together. I guess I'd love to see a copy of that deck. I might read through it one more time.
Sure.
But yeah, thanks again, man.
No problem.
All right, guys, I'll talk to all of you later.
Okay, see you.